ABC is a cyclic quadrilateral. The opposite sides, when extended, meet at P and Q as shown. The angles alpha, beta and gamma are as shown. Prove that beta plus gamma equals 180 degrees minus 2 alpha. We will be using the following theorem. The opposite angles of a cyclic quadrilateral sum to 180 degrees. As I've mentioned previously, a cyclic quadrilateral is a quadrilateral through which a circle can be drawn. The circle will touch the four corners. So A, B, C, D is a cyclic quadrilateral. So its opposite angles sum to 180. So if this angle is alpha, then this angle is opposite alpha. And these two angles sum to 180 degrees. So this angle here must be 180 degrees minus alpha. Now we see that these two angles here must sum to 180 degrees, because if we put these two angles together, we get a straight angle or a straight line. So this angle in here must be alpha, because if we add alpha onto 180 minus alpha, we get 180 degrees. Now if this angle is alpha, then this angle over here must be alpha, for the same reason, because this angle plus this angle form this straight line here. Another way we could see that is to say that this angle here is opposite this angle. So we could talk about opposite angles, or we again could talk about two angles forming a straight line or a straight angle. Now let's consider this angle here. We can find this angle in terms of alpha and beta, because the three angles in this triangle add up to 180 degrees. So this angle must be 180 degrees minus these two angles, minus alpha minus beta. And over here we have another triangle, triangle CDQ. The three angles in it add up to 180 degrees. So this angle here must be 180 minus alpha minus gamma. Now let's look at this angle. These two angles add up to 180 degrees because we have a straight line. So to find this angle, which I'm showing in green, we have to take 180 and subtract this from it. So we have 180 minus this angle here. 180 minus alpha minus gamma. And what do we get? Well, 180 minus 180 is 0. If we take the minus sign in, we get plus alpha plus gamma. So this angle is alpha plus gamma. Similarly over here, these two angles add up to 180 degrees because we have a straight line formed. So to find this angle, which I'm indicating in green, we take 180 degrees and subtract the angle next to it. So we must write this in brackets. It's made up of three terms. When we take the minus sign in, you can see the 180s cancel. We get minus minus alpha, which is plus alpha, minus minus beta is plus beta. So we end up with alpha plus beta. This makes sense because if we add these together, alpha plus beta plus 180 minus alpha minus beta will give us 180 degrees if we add these together. Just like the sum of these two angles will give us 180 degrees. But we can see that this angle, which is CDA, and this angle, which is CBA, are opposite angles of a cyclic quadrilateral, of the cyclic quadrilateral ADCB. Because they're opposite angles of the cyclic quadrilateral, they must sum to 180 degrees. So we add these angles together, set them equal to 180 degrees, and we can then derive this result here. We just leave beta plus gamma on the left hand side and bring the two alphas to the right hand side.